Alright everybody, welcome back to my channel. Today I want to do a real quick video on DHCP and DHCP relay. I think the most important part of this video here is DHCP relay. Everybody, if you're not aware of what DHCP is, it's a way to dynamically receive an IP address. It's mostly found in any type of network, really. Even your home residential network has a DHCP server probably running. It's just a way for clients to get IP address information, subnet mask, default router, among other things. But those are the three important things that it receives from a server, which keeps track of this information and kind of makes it so that you don't receive a duplicate address, which would be very problematic. And there's also other uses for DHCP servers, such as setting TFTP servers, DNS servers that you can use, things of that nature. So if you're a network engineer, most likely you may not manage the DHCP server. It's usually probably a dedicated Windows server that hopefully a server team is running, and you're not also responsible for that server. But as a network engineer, you're responsible for the client having the ability to reach that server, connectivity. So that is where DHCP relay comes into place. As a client, when this client requests an address, it's going to send out a discover message, which is a broadcast message, but it does not traverse a layer 3 boundary by default. So, for instance, if this client was on this segment of the network and it sent out a discover message, the first layer 3 device that it hits, the first layer 3 threshold, so to speak, that it hits, this discover message is going to die. It's not going to traverse it. So that would be this line right here. So if there was not a DHCP server running on this router and there was not a helper address on this interface to tell it where to go, that request would die. And you will be troubleshooting it for a long time because you'll be saying, I have a DHCP server over here. It's connected. This DHCP server has connectivity back to this router, but guess what? You never configured an IP helper address. So the router doesn't know where to send this request. That is the key point with the IP helper address. It tells this interface where your DHCP server is so that this discover request can traverse layer 3 boundaries. So with that being said, let's take a look at the packet capture and see a broken process, and then we'll configure this IP helper address, redo the request, and see an actual complete DHCP process successfully displayed in Wireshark. Okay, so we're going to capture on this segment right here. And we are going to start Wireshark. We're going to go back. And we're going to kick off a DHCP request. This is without relay in place. So right now, this request is dying right here because there's no DHCP server on this router and there's no IP helper address. So look, it just died. 3 Ds. You know what that means? That means 3 discover messages that never reached DHCP server. So this is what they look like from the client. Obviously, it doesn't have an IP address right now, so the source is all zeros. The MAC address information is going to be populated because MAC address layer 2 doesn't deal with DHCP server, doesn't care about DHCP. Your client's always going to have a MAC address. It's never going to dynamically get a MAC address. It's going to be static. So it's going to have the MAC address portion of the frame filled out. The IP address, however, is going to be all zeros, quad zeros, and the destination is going to be a broadcast. So any server that's listening on this layer 3 segment. But guess what? There was no server listening on this layer 3 segment. It was on the next segment, so it needs help to get there. So let's go back in here and let's do one quick command on this router. So we're going to first show the interface, the configuration of this interface facing the client. Fast Ethernet 00 has an IP address. That's it. Let's go into it. And we're going to say IP helper address 172.16.1.2. That is the address of your DHCP server, and you must have connectivity from this interface to that DHCP server, because this router is going to forward that discover message to this DHCP server, and the source is going to be this interface right here. So we're going to give it the helper address. Now, if we spin back up Wireshark and we do another IP DHCP request on this PC, we should have a completed process, and we do. Okay, perfect. So let's stop the Wireshark capture there. So we can see the same thing. The client, all zeros, because it does not have an IP address, is going to send to the broadcast at 255.255.255.255, and guess what? We received a response. Okay, so we received a response, and the client knows that this is its DHCP server, 172.16.1.2. It doesn't look like that in the packet because the packet got encapsulated and de-encapsulated with the router's IP address information, right? It's going to say this is your address right here, 192.168.1.2. That's the offer. And now, guess what? The client still doesn't have an IP address, right? Because it's just the offer. It hasn't been confirmed yet, or ACT. So this client still has all zeros as his IP address, and he's still broadcasting. So guess what? That DHCP relay command is still in play. It's not just used for the initial discover. It's used throughout the entire process. So now it sends a request back to that DHCP server. And then finally, the client is going to say, okay, here's an ACK. I ACK that you now have this IP address, right? You now own this IP address. This is the DHCP server, the identifier, and this is the relay, the agent address, right? So the relay agent, so the liaison, our router 1, whatever has the IP helper or relay command configured, and then this is gonna be your IP address. So that is DORA, discover, offer, request, acknowledgement, as it pertains to IP DHCP relay. So I hope that's been informative or explained a little bit, at least with the packet capture, the process of what's happening. I know we've all seen that helper address command configured on interfaces, but when things get a little weird and you need to start troubleshooting, it's helpful to know how these packets are traversing your network and how the process is supposed to look. So leave me any comments or questions down below, and I hope this was helpful. So thank you.